So the most important part of the chapter we're going to look at now is covalent bonding, and that probably makes up the majority of the test. Most of the points will come if you're wondering about tests and how it's going to be structured, but most of this test is going to be over this. Okay, this would be the highest number of points. So what I've laid out in front of you is 6 steps to go through and draw what we call a Lewis structure. Lewis structure is developed as a model to show how atoms bond together covalently. And there's multiple ways in which they can go together. And what we're going to do is go through these 6 steps, and then after going through a couple of these, one on just step by step, another one you'll practice a little bit, and we'll double check along the way. Covalent bonds make up probably over 90% of all compounds. So all compounds, when they're bonded together, are made up of atoms that share electrons. That's basically what it is. And it's a small percentage of the elements. It includes hydrogen, carbon, nitrogen, oxygen, fluorine, chlorine, sulfur, iodine, bromine's in there. So it's a very small segment of the periodic table. Probably 10% of the periodic table make up all of the majority of the compounds. Okay? The reason why is they can hook together in long chains. They're not limited to just a set ratio like we did on that last one, but they can make up long chains of carbons that are hooked together in a variety of different ways. So when you get into pharmaceuticals, you get in to go to school and want to be in the pharmacy, something like that. Basically, there's so many different divisions in which you could go. You can do research, you can do things with medicine, you can be behind the counter pharmacist, but all of it has to do with basically elements covalently bonded together. So this is kind of the first type of thing that we'll do where you'll structure them together. And what they're called Lewis dot structures to begin with. So what we'll do is we'll take a look at the Lewis dot structures. And if you're following along, you can just write on this sheet, and this could be your notes, and this could be something you refer to from time to time. So these are called Lewis dot structures. Okay? So the plan is for us to go through and kind of look at how something's put together covalently. And there's rules we have to follow. The rules we have to follow is that we can't use any more electrons than what we start with. It's kind of a conservation. We have to conserve the electrons that we have. We can't make up electrons. We can't make them up out of thin air. We can't limit how many we use or use less. So one rule we have to always adhere to is when we write down a number of electrons, we make sure that's what we use in our structure. We can't use any more or less. It has to be a perfect amount. That number is always going to be even, too. So when we have number of electrons, since they pair up, and they're going to be paired in orbitals, they're always going to be even. So we're never going to have an odd number of electrons when we're done writing our structure. Always going to have an even number, 2, 4, 6, 8. That's kind of what we're going to take a look at, how we write it. So to begin with, what we're going to do is give you a formula of a molecule. So these are all molecules. Molecules are, I guess, they're substances that are held together by covalent bonds. That's a molecule. H2O is a molecule, CO2 is a molecule, and they exist as that ratio, okay, as that entity. So we'll go ahead and do one. We'll go S, H, and I. Now the first thing it says on the sheet I gave you, number 1, draw out the correct electron dot notation for each atom in the formula. If there are two or more identical atoms shown in the formula, make sure to write dot notation for each identical atom. But we don't have an identical atom here. We'll do that the next one. So go ahead and write your dot notation for each one of those. Okay, so we did that successfully, and then step number two says, add up the number of dots around each dot notation and write down the total number of valence electrons. Okay, so we get this word called valence. We've never seen that before. It talks about valence. Well, valence electrons are just electrons in the outer shell. So if I say, hey, it's got 6 valence electrons or 1 valence electron, it just means those electrons in the outer shell. And they're usually the ones involved in sharing, transferring, those type of things. So count how many you have and then write that down. So we have how many? How many total? 14. Now, that means that there's 7 pairs. Okay, so we're going to have 7 pairs. But we have a total of 14 electrons. So at this point in time, we've got to start thinking about our structure and what it's going to look like. And the most important part of this is determining which one of those elements are going to be in the center. So we got to decide which element, sulfur, hydrogen, or iodine, is going to be in the center. How you determine that is by looking at which one requires the most electrons to get 8. So it would be the one with the fewest electrons. Now, I need to warn you that hydrogen looks like it needs a lot, but really only all hydrogen needs is how many to get a full shell? 1. So hydrogen will never be in the middle because it always just needs 1, and then there'll be always something that needs more that's going to be in the center. So we've got to pick a center atom. So which one do we need to choose? Sulfur. So in step 3, we need to put sulfur in the middle, and then what we need to do is to surround it with the other atoms. And it doesn't really matter the position of the symbols. Okay, don't get caught up that if I put an H here and you put an H above, then you're wrong and I'm right, or I'm wrong and you're right. It doesn't really matter because that can rotate. That molecule is not stuck there, it's free moving and can rotate and move around three-dimensionally. So it does not really matter where you put them at. I always like to put them at 12 o'clock, 3 o'clock, 6 o'clock, or 9 o'clock, but I mean, it really doesn't matter. That gives you good spacing in that when you do that. So we go ahead and do that. So we're good there. We're not going to include any electrons at the time. Now number 4, we're going to place a pair of electrons in between the central atom and the outer branched atom. So guys, underneath number 3, you could just go ahead and continue to build on your structure. Because under number 3 is probably where you put this structure. So what we're going to do, the atoms on the outside of the central atom is called branched atoms. So what we'll do is we'll make a connection between the branched atoms and the central atom by drawing a pair of electrons. And what that says is that sulfur is bonded to iodine, and sulfur is also bonded to hydrogen. And iodine and hydrogen are not bonding together. So these two, and central atom is a connecting atom that connects everything through that central atom. So we always want to keep track of our electrons so we don't you don't use too many or too few. So we've got 10 electrons left over. Okay? Now, number 5, the last step, it says any of the remaining electrons need to be placed around the branched atoms to complete an octet of electrons for each branched atom. So an octet of electrons just means 8, 4 pairs or 8 electrons. So we will not put any around hydrogen, right? Hydrogen doesn't require any more than the 2 that it has to begin with. And so we're done with hydrogen after we do our sharing, our pair. Next thing we'll do is we'll look at our branched atom. Here, iodine's a branched atom. So we'll go ahead and put our electron pairs around iodine so that iodine has 8. So there it has 8. Okay? So we added 6 electrons. We'll take that away. And we're left with 4 electrons to position. Number 5 also says if any electrons remain left over, we have 4 of them, after supplying octets, complete an octet around the central atom if you can. So we got 4 electrons or 2 pairs, we're going to put it around the central atom. Okay. If, after you're done with number 5, everything has 8 electrons around it, you're good to go. You're done. If you get to 5 and you notice that the central atom does not have 8 around it for some reason, and that'll be tomorrow, then what you need to do is you need to continue on and do number 6, but we won't do that today. We have an easy day. We'll just deal with showing these structures. Let's take a look at our original ones. So here's sulfur. Sulfur needed 1 there and 1 there to get 8. And so if you notice that hydrogen needed that 1, so that hydrogen would go there. And I have if I did it right, I would have positioned it just perfect, and we could do that. And then iodine, see, it needs its 1, and so it will come over here and attach itself. So that's kind of what we ended up with after those 5 statements. Okay? That's kind of what we did. It's just an easy way to show that connection. So now everything has 8. Iodine has 8, 2, 4, 6, 8. Sulfur has 2, 4, 6, 8. Hydrogen has 2. This is called Lewis dot structure. What we want to do is we want to rewrite that so we clean up some of these dots around the branched atom. So what we'll do is we'll do what's called a structural formula. And to do that, we'll put sulfur still in the middle, and then iodine, we're going to show a line, and that line's connected to iodine. And then we're going to show a line and show it attached to hydrogen, just with a line instead of dots. And then we need to include, this will be, some of you guys will forget this, but try not to forget, we want to include the dots on the central atom all the time. The branched atoms we're not going to, but the central atom we are. And this is the reason why. It's because later on we're going to go ahead and describe these shapes. Because every molecule has a specific shape. And we're going to describe those shapes. And to do that, we need those electrons shown on the central atom. We don't need it on the branched. Okay? So that's all of it in a nutshell. Steps 1 through 5. This is the Lewis dot structure, since it's just all dots. And the structural formula is something you probably see in textbooks. That's what you'll see in textbooks is, you know, when you guys see methane in a textbook, okay, it's going to look like this. It's not going to have any dots on it. So there's methane. Okay? Or if you see CO2 in a textbook, it's going to be like this. That's double bonds. You got 2 lines, you got double bonds. If you got water, it'll be in a textbook probably like this. Okay? And then we will show the dots around it so that we can you guys can determine the shapes in that. But that's kind of what we're looking at, is to look at, when I say textbook, I'm thinking life science, earth science, where you guys haven't had any chemistry, they'll just show it like that. Yes?
So the dashes, those mean like two dots, basically?
Yes, one dash is like this. So basically, it's kind of like this. You guys will put these structures together on Monday when we start doing it. But it's kind of like, it's really resembling a dowel, wooden dowel. It's kind of like, oh, that's a wooden dowel. And it shows a single bond. Because later on we'll show triple bonds, and that's 3 pairs of electrons in between. And that gets really messy. So if we can clean it up and just show lines, then that kind of diverts that. Like an iodine, look how it's a lot better because I don't have to show the iodine electrons when I do that. Yes, Jaden?
Alright, so for this, I'm going to use the example today. Would it be possible for, say, the hydrogen and iodine to like
Switch?
to like bond, like be able to bond?
It could be possible. What happens, that puts a lot of stress on the structure. We'll have what's called cyclic structures, and cyclic structures would be like this, Jaden. We would have carbon here, carbon, carbon. So they're all bonded together. Sugars are made of this. If you guys look at sugars, sugars will look like this. They'll have a cyclic structure. So you get into when you get into amino acids and sugars and starches and those type of things, they will have these ring structures. So it's possible to ring together. But for right now, no, we're not going to deal with any of those. All right, something we need to do is just have you guys walk through an example on your own. And so we're going to go ahead and do P, H, F2. PHF2. Now, this is when you read down the directions and we have 2 fluorine. And F2, that means we got 2 fluorines we have to write out. So we have to write the identical one out. So go ahead and do the first 2 steps there. Or 3 steps. So after your first 3 steps, that should be something. I don't care where the H's are and the F's are. It doesn't really matter because that depends upon 3-dimensionally where it's going to be at. So you don't have to write it exactly like I have it. So then we have to start. First thing we do is we pair up our branched atoms. After we get done with the branched atoms, we go ahead and get 8 electrons to the branched atoms. And then at that point, we'll see where we're at. Okay? So we are on step number 4 and 5. So do 4 and 5. If you haven't done so already, just go ahead and do 4 and 5. Okay, so we do, I haven't finished all of 5, but 4 was to place your pairs in between, and that added up to be 6 electrons. Then we subtracted that out, and then we decided we had 14 left, and then so we went around the outside of each of the branched atoms. That was a total of 6 and 6 is 12 electrons. So then after we put the 12 electrons in there, we're left with 2. And so anything remains can go off the central atom. So we put them off the central atom, and we're done. We run out of electrons. We're done. So then you double check your structure, and you got 8 and 8, and phosphorus has 8. So everything has 8, except for hydrogen. And then if we would rewrite that, and then it would be written like so. Here, you got P dash H dash F dash F, and then you would show your pair there. And that's called the structural formula. Cleans it up, we don't have to show all the dots at that point in time. It makes it kind of easier to see what's going on with that. So that's the structural formula. So what I have for you to do, in your notes, you can do it for tomorrow. You can do CH2, Br2, NHI2, and SClF. Okay, so if you can do those 3 for tomorrow, showing the final 2 structures, the dot structure and structural formula, that's what we want you to do.